Before I discuss what design validity is, I want to go over an example that shows why it's important. On the right here is a graph from a study done in the 1930s to look at whether feeding children milk leads to weight gain. This was a study done in England. They took 10,000 school kids, gave them extra milk. 10,000 other school kids served as controls. They got no extra milk at school. Uh, at the end of the study, what they found was that the kids who were given extra milk, gained more weight. Did that cause the weight gain? And if you look at the graph, just looking at this, it's hard to tell whether anything is amiss. So the dotted lines, those are the results from the kids who got the extra milk. The solid lines are for the kids in the control group. And if you actually know what's wrong with the study, then some things start to jump out at you. So in this case, one thing that's important to notice is that in each case, and they've broken the kids up into different age groups, the kids who got the extra milk were always started off weighing less than the kids in the control group. And if this was truly randomly assigned, you would expect them to be pretty similar, or you might expect, in some cases, the kids who started out getting milk to weigh more than the kids who did not. Uh, a second thing that jumps out when you know something is amiss is that when you look at where the kids in each age group ended, you see that they're not really close to where the kids who are the next age group up started. So you would expect that by the time they reached this age, they would be further up here to where the kids in the next age group started just because of time. And the reasons for both of these problems comes from some threats to validity of this study, some things that they did that made the study less valid and less strong. So one thing that happened was that the teachers didn't assign the kids randomly. What they did was they took the kids who were not getting enough food at home and put them in the group that got extra milk. So they knew that there were some kids that were not getting enough nutrition. They put them in the extra milk group, which was the compassionate thing to do, but it did mean that in each case, the kids that weighed less, who weren't getting fed enough at home, were all in the milk feeding group. So the milk feeding group always started out weighing less than the other group. Now, the other problem they had was with how they measured weight. So the way they did it was they brought the kids in and they put them on the scale fully clothed. But they started the study in February when the kids were wearing heavy winter clothes, and they ended the study in June when the kids were wearing lightweight summer clothes. And they didn't correct for that in the way that they measured the kids. So they weighed more in the winter than they did in the summer, and that's why these bars were not as steeply sloped as they should have been. And both of these problems are issues with what we call design validity. We've talked about the validity of an individual outcome measure, and that means and when we're talking about validity of an outcome measure, we're talking about, are we accurately measuring what we think we're measuring? For the validity of a study, here we're talking about quality assurance. Is the study measuring what we think the study is measuring or proving what we think the study is proving. It comes down to a matter of quality assurance. There's 4 kinds of design validity that we're going to discuss, and this figure comes from the Portney and Watkins textbook. There's statistical conclusion validity, internal validity, construct validity, and external validity. This table also comes from the Portney and Watkins textbook, and what it shows is that there are a lot of different ways that validity can be threatened. And over the course of the semester, we're going to go into many of these in some detail. Statistical conclusion validity, the question there is, do the numbers add up? Are we using the correct statistical analysis to draw the conclusion that we're drawing? And when we get to discussions about the results sections of papers and the method sections where they talk about what kind of statistical analysis they did, that's where we'll be talking about statistical conclusion validity. Internal validity, that's did they eliminate potential confounders, right? Did they use control groups? Did they design the study in a way to eliminate other potential explanations for what they found? So that's internal validity is really a question of, did they design the study well? Construct validity is a question of the fine print. Were they really measuring the things that they said they were measuring? And were they really testing the things they thought they were testing? This comes down to things like if they're testing a particular intervention, so constraint-induced movement therapy, how long did they apply the intervention? How was that intervention implemented? And then when they went to measure the outcomes, how did they measure range of motion? How was that defined? Construct validity is especially important when you've got complex interventions that have multiple parts, or maybe they're being done at home, outside of the supervision of a clinician. And also when you've got outcome measures that aren't these clearly objective measures like range of motion, things like pain or quality of life, things that are a little bit harder to define and measure. We've talked about construct validity of a measure as well. With construct validity of a measure, we're looking specifically at, am I measuring what I think I'm measuring? When we talk about construct validity of a study, it's, am I testing what I think I'm testing? External validity, that's how do the results of the study apply beyond just the people and the setting in this study? So if I've done a study looking at kindergarten through 6th graders, that the results of that study may not apply to high school students or college students or older adults. That distinction of external validity is different than internal validity. In external validity, we're looking at, is this going to apply beyond just the people in place where this study was done?